This is a sellotape roll, so I'm going to roll it from here. This is part A and that's part B. This sellotape roll, it rolls in a straight line from part A to part B. Now if this sellotape roll is to roll from part A to part B in a straight line and it is not interrupted, it means it will have covered a certain distance in a certain time frame. Now let's assume that the distance between A and B is 100 kilometers, and this sellotape, when it was running from A to B, it did cover this 100 kilometers in a certain time frame. So if we wanted to find the speed by which this sellotape roll was able to move from this point down to this point, for us to be able to find that speed means that we are going to get the total distance covered from A to B, and we divide that by the total time taken for the sellotape roll to move from A to B. And in that case, it means that to get the distance covered means that it's going to be 100 kilometers, which is the distance covered. Divide that by the 2 hours it took. We are now assuming that it took 2 hours to move from A to B. So for us to be able to get the answer here definitely is 50 kilometers, and it is going to be 50 kilometers per hour. That is the speed. Now 50 kilometers per hour means that if this sellotape roll continued to travel even beyond the point B and it continues moving in a straight line without interruption, it means that for every 1 hour it will be covering 50 kilometers. That is what we mean by 50 kilometers per hour. That for every 1 hour it will be covering 50 kilometers. And this is definitely what we call constant or uniform speed. Just like we've seen before, the formula for finding constant or uniform speed is simply going to be equal to the distance covered divided by the time. So we get a kind of formula that constant speed is going to be equal to distance over time. And if we are to make this a flat equation, meaning we multiply time on both sides to make it a flat equation to eliminate this fraction, it's going to become distance traveled is going to be equal to speed times time. So in most of our workings where we are going to get, we will be dealing with motion in a straight line, it is very important that we commit this to memory, that distance traveled is going to be equal to speed times time. But you realize that speed shares the same units with velocity. For example, if you have to look at it here, we know that velocity is the measure of speed in a specified direction. So this brings us to the difference between these two. Speed is a scalar quantity, velocity is a vector quantity. We all know that when we are talking about scalar quantities are simply physical quantities that only have magnitude, and these ones include things like mass, density, area. And then vector quantities are physical quantities which have both magnitude and direction. And here we are talking about things like velocity, we are talking about things like acceleration, displacement, and so forth. So speed and velocity have the same units, only that one is a scalar quantity, the other is a vector quantity. So when we are talking about speed and velocity, the units will always be the same. We'll head straight into a few examples. Find the distance traveled in 5 hours by a body moving at a constant speed of 30 kilometers per hour. So to summarize our question, we have our time there being 5 hours. And we are talking about a body moving at a constant speed of 30 kilometers per hour. So it means that the speed, which I'll call it V, is going to be equal to 30 kilometers per hour. So they're asking us to find the distance. Distance, which we shall denote by S, is going to be equal to speed, which is V times time. And now our value of V is 30 kilometers, so it's 30 kilometers per hour. Multiply that by the time taken, which is 5. And definitely here, this is 5 hours. So it means that 30 times 5 is 150. So our distance is 150. And of course, this hour and that hour cancel, remain with kilometers, so it's kilometers. So our distance traveled there is 150 kilometers. A body traveling at a constant speed covers a distance of 4 kilometers in 3 minutes. Find the speed of the body. So we know that the body is traveling at a constant speed. So the constant speed V. The constant speed is not given, you're supposed to find it. Covers a distance of 4 kilometers. So the distance S is 4 kilometers in a time frame of 3 minutes. So the time given here is 3 minutes. And so here we need to find the speed of the body. So definitely we know that the general formula is that the distance is going to be equal to speed times time. We know that the distance is 4 kilometers is going to be equal to the speed, which is not given, which we are looking for, times the time, which is 3 minutes. Now for us to find this, we are supposed to make sure that our units are harmonizing. We are having our distance here in kilometers and our time here in minutes. It means that our speed will be in terms of kilometers per minute. Now we need to convert these minutes to hours so that the speed we are able to get is in kilometers per hour, not in kilometers per minute. So it means we first convert these minutes to hours. Converting that to hours means we're going to divide this by 60 minutes. So we make V the subject of the formula and find the value of V. So here when we make V the subject of the formula in this case, this 60 is multiplied on both sides and then we divide both sides also by 3. You end up with 4 kilometers here, this is in kilometers, and multiply that by 60. 60 is in, of course here 3 over 6, these minutes cancel and you remain with 3 over 60 hours, because we are converting these 3 minutes to hours. So it means that here we're having kilometers and we're dividing that by hours. This is 3 over 60 hours. So for us to have gotten these units meant that it is 4 times 20. What we're getting here is 80 kilometers. Divide that by hour, that's why we call it kilometers per hour. And that is the speed. Speed of light is 3 times 10 to the power 8 meters per second. If the distance from the sun to the earth is that, find how long it takes from the sun to reach the earth. So to find the speed, we know that distance, which is denoted by S, is going to be equal to speed times time. The speed of light is that. So it means that the speed of light is going to be 3 times 10 to the power 8 meters per second. If the distance from the sun to the earth is that, so meaning that if the distance S from the sun to the earth is 1.5 times 10 to the power 8 kilometers, find how long it takes. So they're asking for the time. How long does it take for the light to move from the sun to reach the earth? So for us to be able to get our value of time, we're simply going to substitute in here. Now please take note of this, that here our velocity is in meters per second and our distance is in kilometers. So now these are kilometers, these are meters. We need to harmonize these units. They are either both kilometers or both of them are meters. But I think it's easier. Let's convert these kilometers to meters, so that when we are dividing the two, these meters cancel out and our value of time is only remaining with per second. So it means that converting this distance to kilometers, we are going to multiply this by 1,000. Of course, when we multiply that by 1,000, it turns to meters. So when we continue with our working, therefore, it's going to become, we know that distance is going to be speed times time. And definitely our distance here is 1.5 times 10 to the power 8. But we are converting these kilometers to meters, so it becomes times 10 to the power 3 as well. Is going to be equal to speed. Our speed is 3 times 10 to the power 8 meters per second. Multiply that by time. So when we make T the subject of the formula to find the value of time, time therefore is going to become Now, of course, when all this is done, we get our value of t as 500. But remember that this top part here with this 1.5 times 10 to the power 8, this was converted to meters, and this downer part is in meters per second. So this is in meters, this is in meters per second. So meaning that this and the meters cancel out, and as far as our units are concerned, our value of time is in seconds, because this is s to the power negative 1. When we shift this s to the numerator, it becomes 500 seconds. And of course, the question does not specify in what unit we're supposed to state the time, so it means we can as well leave our time in seconds, and that is just fine. Let's say somebody is driving along the road, and as they are driving, they're going to start from this point. As they are driving their car, they're supposed to follow this path and reach their destination at this point. But as they are driving, we assume that as they start, you start at a lower speed, like 20 kilometers per hour. Then you start accelerating, and this speed will slowly start increasing to, let's say, 30 kilometers per hour, 40 kilometers per hour as you're moving along the straight track. But we all know that as you're moving from this point, when you are approaching the corner, you're supposed to reduce speed, because you cannot go and you cannot negotiate this corner in this constant speed. So it means that as you're approaching the corner, you're going to reduce speed. So if, let's say, you were coming in at around 60 kilometers per hour, when you reach the corner, you're going to reduce to around 20 kilometers per hour. You will negotiate that corner, then you will accelerate again, you increase speed, then you reach the corner again, you're supposed to reduce speed so that you negotiate the corner. Then you will increase speed again to something like, let's say, 60 kilometers per hour. But you, as approaching the corner, you reduce speed to, let's say, 20 kilometers per hour, so that you're able to swerve that corner again, and so forth, until you're able to reach your destination. So what am I trying to say? What I'm trying to say is that if a person is to move from this point to that point, it is impossible in real life for them to be able to use constant speed to move from here, unless the path is completely straight. But in most cases, as we are moving, you will encounter a bicycle along the way, you will encounter a motorist, you will encounter another road user along the road, and these people are going to definitely cause you to have to reduce your speed. So because of these speed variations, we are always unable to move at the constant speed from where we started from to where we ended. So because it is impossible, when we are calculating, we definitely have to find the average speed now, or we'll call it the average velocity. So the average speed will mean that we're supposed to get the total distance covered, and we also get the total time from this point to that point, and when we divide the two, we are able to get the average speed of this person. And definitely, of course, the average speed simply signifies the constant speed this person would have traveled without having to reduce speed and all that. So for us to get the average speed, we simply are going to get the total distance and divide that by the total time, from the point the driver started driving to the point where they ended. It's the same thing. Average velocity is going to be the total displacement in a specified direction between, and divide that by the total time. Now I have to explain. These two, average speed and average velocity, they both have the same SI units. Average speed it will have the same SI units as average velocity. It's all in meters per second or kilometers per hour. Now, what's the difference between average speed and average velocity? Why do these two have the same? Why do they have the same SI units, but if you look at them, they are having different formulas? Now, let me explain some theory here. When we are talking about average speed and velocity, though they have the same SI units, they are different because one is a vector quantity, the other is a scalar quantity. Now, just to take us back to our theory, a vector quantity is a physical quantity that has both magnitude and direction. And a scalar quantity is a quantity that only has magnitude and does not have direction. Now, in this case, velocity is a vector quantity because it has both the magnitude and the direction. But speed is only a scalar quantity because it only has magnitude and no direction. Now, of course, other examples of vector quantities, we have acceleration, we have displacement. Then for speed, of course, for other examples of scalar quantities, we have density, we have pressure, we have mass, and so on. We'll look more into those details when we are dealing with vector and scalar quantities in the physics videos. So because this is a scalar quantity, speed, so we are going to, it will be total distance divided by total time. Again, distance and displacement have the same SI units. They are both can be measured in meters. But distance, by definition, is simply the space between 2 points, and then the displacement is simply the distance between 2 points in a specified direction. With distance is concerned more on the magnitude. We'll talk about distance to be things like 10 kilometers, 20 kilometers, 30 kilometers, but those 10, 20, 30 kilometers, their direction is not defined. This distance becomes displacement when we define the direction of the distance. So for example, if we talk about things like 10 kilometers in the north direction, now that becomes displacement because it is having both magnitude and direction. If we talk about things like, let's say we are moving 100 kilometers south. So 100 kilometers south becomes the displacement because it has both magnitude and direction. Then so basically it's total distance over total time, also total displacement over total time. It's more of the same. It's just the theory that makes these two stand out to be kind of different. So we'll do an example here to illustrate this. PQR are points along a straight line in that order, where PQ is 40 kilometers and QR is 90 kilometers. A man travels from P to Q and from Q to R at 10 kilometers per hour and 15 kilometers per hour, respectively. Calculate the time taken between P and Q. Now, when we say kph, we shall be meaning kilometers per hour. So now to do this example, we are going to go ahead and do Roman 1, the time taken between P and Q. Now, before we calculate for the time taken between P and Q, we need to summarize the question in a diagrammatic way. These are PQ and R as points along a straight line. So we are going to illustrate those in the diagram. So we have P, Q, and R. Now they're telling us that PQR are points along a straight line where PQ is 40 kilometers. So from P to Q, they are 40 kilometers. And then Q to R is 90 kilometers. And also, as this man is traveling from P to Q and then from Q to R, he travels at 10 kilometers per hour. This 10 kilometers per hour is the speed he uses to travel from P to Q. So meaning from P to Q is 10 kilometers per hour. And then from Q to R, and from Q to R, he's going to move at 15 kilometers per hour. So these 15 kilometers per hour are traveled from Q to R. Roman 1, they're asking us to find the time taken between P and Q. Now, the time taken, we know that distance is going to be equal to speed. Distance is equal to speed times time. So now, since they're asking us to find the time, we have the distance, which is 40 kilometers. We have the speed, which is 10 kilometers per hour. So to find the time taken for the object to move from P to Q, we'll make T the subject of the formula. Of course, distance, we denote it by S, is going to be speed, which is V times time. So to make T the subject of the formula becomes T is going to be S over V, which is going to be equal to our distance between P and Q is 40 kilometers. So it's going to be 40 kilometers, divide that by the speed, which is 10 kilometers per hour. So which is divide that by 10 kilometers per hour. Of course, the kilometers will cancel, those that 0 will go with that. You will remain with your answer as 4. This is hour per hour. The hour comes up, it becomes 4 hours. So it means that the time taken to move from P to Q is 4 hours. So Roman 2, they're asking us to find the time taken between Q and R. That's the second part of the motion. We are going to do the same. the time taken between Q and R, still we are going to use this. T is equal to S over V, and we find the time. So T is going to be equal to S over V. The distance between Q and R is 90 kilometers. Divide that by the speed between that, which is 15 kilometers per hour. The kilometers will go by 15 once. By 15 we have 6. So the time taken between Q and R is actually 6 hours. Roman 3, they're asking us to find the average speed between P and Q. Now you realize that as this body was moving from P to R, it was moving at various speeds. When it moved between P and Q, it was moving at 10 kilometers per hour. Then from Q, it increased its speed to 15 kilometers per hour. So it means that for us to find the average speed of this, means that we are going to find the total distance covered, which for PQ, divide that by the total time. That's going to be total distance, divide that by total time. So to find the total distance is adding up the two distances. We know that from P to Q is 40 kilometers, and then from Q to R is 90 kilometers. So it's going to be 40 plus 90. All this distance is in kilometers. Divide that by the total time. Now, from our earlier calculations, we know that the total time taken from P to Q, we got 4 hours plus the 6 hours. The 6 hours is the total time that was taken from Q to R. We calculated that earlier. So our answer here is going to be 130 kilometers. Divide that by 10 hours. And so definitely our answer here is going to be 13 kilometers per hour. Kilometers per hour. Now this you can also write it as 13 kilometers per hour, or you write it as 13 kilometers per hour. Either way, it's correct. Still another example to help us illustrate the difference between average speed and average velocity. Remember, we said that speed is a scalar quantity with only magnitude. Velocity has got both magnitude and direction. Now we have a question here that says that a man walks 400 meters due east in 190 seconds and 100 meters due west in 50 seconds. Calculate A, his average speed, and B, his average velocity. So this is how we are going to do this. Let's try and summarize this question using a diagram, illustrating this diagram. A man walks 400 meters due east. So as he's walking, let's say this is the spot he starts. When he is walking, he's moving due east. And the question says that he's going to move 400 meters in the east. And then when he reaches that point, after 400 meters, then he does this in 190 seconds. So meaning it's 400 meters are done so in 190 seconds. That's the time it takes. And then he's going to move 100 meters due west in 50 seconds. So he moves 100 meters west. So we will move other 100 meters west in 50 seconds. So he'll move that in 100. So he will end up somewhere there. He started from here, he moved, and then came back and he stopped there. So this kind of illustration, this kind of question is trying to demonstrate to us the magnitude of the distance, which is 400 meters, and it's going ahead to tell us the direction in which it moved. So it is describing both the magnitude and direction. So if you are to find its average speed, remember, when we are coming to average speed, we only concerned with magnitude. It's going to be the distance covered, divide that by the time taken. But when it comes to average velocity, we are going to concern ourselves with the displacement. So let's go ahead and start working. Average speed. Total distance covered here, the guy started from here. He moved 400 meters that way, plus 100 meters. So the total distance covered is going to be 400 meters. Add that to 100 meters. And divide that by the total time when he was moving the 400 meters, he moved for 190 seconds, and also when he came back he moved only for 50 seconds. So the total is going to be 500 meters. Divide that by the total time taken. The total time taken is definitely going to be so the time taken, the average speed is going to be 1 meters per second. Meters per second. So now let's look at the average velocity. What is this average velocity? Again, average velocity formula is, now remember here when it comes to average velocity we are going to be dealing with displacement, not distance. Remember that with distance we were dealing with just the magnitude. The guy moved 400 meters in that direction, then came back. So the total distance moved is simply 400 plus 100. We do not mind about the direction, as we just talk about the distance the guy moves. But when it comes to displacement, even by definition, displacement is the distance moved in a specified direction. So meaning that if this guy started moving from this point, and this is where he ended, the distance he moved is 500 meters, but his displacement is not 500 meters. We say that displacement is the distance moved in a specified direction. So meaning that if he started from this point and he ended here, it means that the distance he has moved in this direction is simply going to be, this is where he started from, this point, and this is where he ended. So if from here to here is 400, then from here to here is 100, it means that the remaining here is going to be 400 minus 100, which shall remain with 300. So it means that much as this guy moved from this point to that point, and the distance he covered to move from here to here, the distance covered is 500 meters, his displacement is 300, because the specific distance covered in the specified direction from the point he started to the point he ended is 300 meters. Again, let's get the difference. Distance is a scalar quantity. Velocity is a vector quantity, and with velocity we are talking about the magnitude and direction. With scalar we are only talking about the magnitude. And so that's the case with distance. Distance is just the how much you move. It's only, distance concerns itself only with the magnitude. So in this case the distance moved to come from here to here is simply 400 plus 100, which is 500 meters. But when it comes to displacement, displacement by definition is the distance covered in a specified direction. So meaning that the displacement of this guy from this point to that point is 300, and it is in that direction. So it means that in this case the displacement is going to be equal to, of course 400 minus 100 remain with 300, so we shall just put it right there, that it's going to be 300 meters. And it's in what direction? It is in the eastern direction. So it's 300 meters in the eastern direction by the time taken. Now of course the time taken to make that displacement to move from here to there is still going to be the same. It's 240 seconds. I mean, right here I moved from here, it's 190 plus that time, which is 50, making it 240 seconds. So it means that our average velocity is going to be 1 over 4 meters per second, and it is in the eastern direction. So our average velocity is simply that, 1¼ meters per second in the eastern direction. Let's try and work out this example. Still we're trying to illustrate how average velocity and average speed differ. A body moves due north from A, 10 kilometers to B. So we'll summarize this question right away with a diagram. We are having a body here, it's moving due north from A. So if this is point A, this body is moving up due north, point A, 10 kilometers to point B. So it's traveling a distance of 10 kilometers to a point up here we are calling point B for 4 hours. So the time taken here is 4 hours. From B, it then moves due south to C at a distance that is 30 kilometers in 1 hour. So as it comes on top up to B, it's going to move back down to another point C, and it is moving from this point B, it's moving down to C, which is 30 kilometers in 1 hour. So it's going to move 30 kilometers in 1 hour up to point C. Now this is 30 kilometers, this is 10 kilometers, this is definitely lower than that. This is longer. So we are supposed to ask to find the average speed. So again, to find average speed, it's going to be total distance, divide that by total time. So the total distance covered here, since we are dealing with distance, when we are trying to find average speed, we deal with total distance. Distance, we are only going to concern ourselves with the magnitude. So the distance traveled from A up to C, it first moves upward 10 kilometers, then downwards 30 kilometers. So the total distance covered is 10 kilometers plus 30 kilometers. It's going to be 10 plus 30. All this is in kilometers. Divide that by the total time. Now the total time covered is going to be upward, it moves 4 hours, then downwards is 1 hour. So it's 4 plus 1, which is 5 hours. And that's going to be 40. Divide that by 5. And of course, this is in kilometers per hour. And that will be equal to 8 kilometers per hour. So the average speed is 8 kilometers per hour. Now we're going to look at the average velocity. The average velocity is going to be the total. So we're going to find the total displacement. Now if you to look at this thing, it is going to move upwards. It moved 10 kilometers northwards, then 30 kilometers downwards. So if we are to restructure this, it is 10 kilometers up, then 30 kilometers down in the opposite direction. So it means that what is the displacement from the point it started to C? If we are to redraw this here to make the displacement issue clearer, this started from A, this is point A, it moves up a distance of 10 kilometers. Then when it reaches to point B, it moves down again another 30 kilometers down to point C. So it means that the total distance moved from A to C, the displacement is this, the specific distance covered in this specified direction. So for me to move from A to C means that it's going to be this 30 kilometers minus that 10 to get the remainder. So 30 minus 10 is definitely 20 kilometers. So to calculate the total displacement, it's going to be 10 kilometers upwards, so we are going to call it 10 minus, because this 30 kilometers is in the opposite direction of 10, so it's going to be minus 30, and that definitely the displacement is due south. Divide that by the total time taken. Now of course the total time taken is the same as before, which is 5 hours. Now of course 30 minus 10 or 10 minus 30 here is going to be 20. Now of course 10 minus 30 here is negative 20. Now that negative is represented by the south because it is 20 southward. So that negative here is due south. So the due south is what is represented by the negative there. Divide that by 5 hours. And of course 20 divided by 5 is 4 kilometers per hour due south. And definitely this is the average velocity of the body. Now you could go ahead and try out that number on your screen. A particle moves due south a distance of 80 kilometers for 2 hours. From there it moves northwards a distance of 120 kilometers for 3 hours. You could go out and try out that number. The average speed I expect you to get is 40 kilometers per hour, and the average velocity I expect you to get is 8 kilometers in the north direction. 8 kilometers per hour in the north direction. Now ABC are 3 points lying in order on a straight line with those dimensions. So we're going to, let's summarize this question. ABC, we have A, we have B right there, we have C. Now ABC are simply 3 points lying in that order on a straight line, with AB giving us 60 meters, so we have down here 60 meters. Then AC is 80 meters, so we move from here to right to there is 80 meters. So if this is 60 and from A to C is 80, so to get BC is simply going to be 80 minus 60 to get the remainder of this portion BC, which is, so that 60 plus 20 is 80 meters. So they're telling us that AB is 60 meters and AC is 80 meters. A body moves from A to B at an average speed of 10 meters per second. So the body moving from here to here, this is the distance, we call it S, and the S there. So it means that the average speed here is going to be 10 meters per second to move from A to B. Then this same body they are talking about, then this same body moves from B to C in a time of 4 seconds. So it moves from B to C in a time of 4 seconds. And then it returns to B. So it means after moving to C, it comes back and returns. It returns to point B. And then it returns to B. The average speed for the whole journey is 5 meters per second. So it means that average speed to move from A, B to C, then back to B is 5 meters per second. So now that we finished summarizing our question, let's look at what they want us to find here. Part A, the question requires us to find the average speed of the body in the second stage of the motion, B to C. Of course, now the second stage of the motion here is B to C is right here, and the question is requiring us to find the average speed. So right here they want the average speed. Then part B wants us to find the average speed of the body moving from A to C. So the average speed moving from A to C. So meaning that we are also required to find the average speed. So the second part of the question wants us to find the average speed to moving from A to C. So we're supposed to also find that. Then also part C, the time taken for the third stage of the motion, that is from C to B. So from C to B, what is the time taken to move for that portion of motion? So the time taken to move from C to B is also required, so we'll mark that as well. Then part D, the average velocity for the complete motion. So this is definitely what we shall do at the very end, the average velocity of the complete motion. So now let's get started with part A. Part A is requiring us to find the average speed of the body in the second stage of the motion. Now this is the second stage of the motion. They want us to find the average speed, so we will go ahead and calculate it. Now we know that the average speed, the formula is going to be equal to the total distance divided by the total time. Now the second portion of the motion, B to C, the average speed we are supposed to find here is going to give us the total distance, which is 20 meters, divided by the total time, which is 4 seconds. So in this case, this is going to become equal to 20 divided by 4. It is 20 meters and these are 4 seconds. So it means our answer is going to become 5 meters per second. And that's our average speed for the second portion of the motion. So we have answered part A. Now part B required us to find the average speed of the body moving from A to C. So we're supposed to find this average speed moving from A to C. To find that average speed, it's going to be equal to total distance divided by total time. So now the total distance moved, as this body is moving from A to C, the total distance is definitely going to be 60 meters plus the 20 meters, which is the 80 meters that were given in the question. So it's going to become 80 meters divided by the total time. Now the total time moved, we do not have the time. We have the time between B and C, but from A to B we do not have the time covered. We only have the average speed and the distance. We do not have the time here. So it means that for us to get the total time of this whole distance, we need to first find the total time here. So it means we are going to do some sort of side work to get the total time here. To get the total time covered between A and B, we know still that distance is going to be equal to speed times time. Now the distance covered from A to B is 60, so it's going to be 60 is going to be equal to speed. The speed covered is 10 meters per second times the time. So when we make t our subject of the formula, t is going to become 60 over 10, which is going to be 6 seconds. So it means that the time taken to move from A to B, the time there is 6 seconds. Now that we have the time covered from A to B, then we have time covered from B to C. So now we can get the total time taken to move from A to C. So we can now continue here with our average speed of from A to C. Our average speed is definitely going to be total distance, which is that of our total time. The total time is 6 plus 4, which is 10 seconds. So it's going to be over 10 seconds. And definitely our answer there is going to be, so our average speed definitely there is 8 meters per second. So we go ahead and answer part C. Part C required us to find the time taken for the third stage of the motion, that is from C to B. So as you're moving from point C to point B, what is the total time taken? Now we know that average speed is going to give us total distance, divide that by total time. And now the total distance, as this thing moves from A to B to C, then back to B. As we are moving from A to B to C, then back to B, the total distance covered is going to be 60 plus 20 meters, then plus 20 meters. So it's going to be 60 plus 20 meters plus another 20 meters. That's the total distance covered. Divide that by the total time. The total time from here to there, we got 6 seconds, so it's going to be 6 seconds. Add that to the total time moved from B to C is 4 seconds. So the total time moved from B to C is 4 seconds plus 4 seconds. Add that to the total time moved from C to B is not known. So the total time moved from B to C is not known, and it is what they want, so we'll call it T. That is going to be give us the average speed. Now the average speed of the whole journey is 5 meters per second. So the rest is arithmetics. This is 100. Divide that by 10 plus t is equal to 5 meters per second. When we make t the subject of the formula, we shall end up with, so we get our value of t here as 10 seconds. So what does that mean? It means that the time taken to move back from C to B is 10 seconds. Then in part D, we are required to find the average velocity for the complete motion. To find the average velocity of the complete motion, the formula will be total displacement divide that by total time. Now of course the total displacement, according to our diagram, the total displacement, we see that this object, the movement is from A to B to C in that direction, then it comes backwards. So it's going to be that in the positive direction minus the distance. Our displacement is moving from here up to there. That's our displacement. I hope we still remember that the difference. Distance is 60 plus 20 plus another 20. But now this is displacement. Displacement is the distance covered in a specified direction. So it means our displacement is just this distance from the point you started to where you ended. That's your displacement. So it means that according to this, our total displacement is going to be from here to there, that is 60 meters. So it means our displacement is 60 meters in the right direction, or let's call it the eastern direction. 60 meters due east, divide that by the total time taken. The total time taken is 6 seconds plus 4 seconds plus 10 seconds. That's going to give us 20 seconds. So it's going to be 60, divide that by 20. And definitely that is going to give us 3 meters per second due east. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.